Continuing with the introduction of different data types in MQL5, now we come to enums, or enumerations. Imagine you want to define a variable that can only take on a limited and specific set of values. For example, in the strategy you've written for your market, the market can only have 3 states: uptrend, downtrend, and range, and it can't have any state other than these 3. The simplest thing we can do without using enums is to define an integer variable. For example, we can name it market status and then assign a definition to it. We say that if this number equals 1, it means uptrend. If it equals 2, it means downtrend. And if it's 3, it means range. So this is one way to actually assign these 3 different states to a variable. But what problem could this kind of assignment cause for us? Imagine you have a large number of such variables. For example, suppose you have another variable called candle status, and you want to define it in such a way that if it's 1, it means the candle is long, or for example, standard. If the value is 2, the candle appears quite long, and if it is 3, it is observed to be spinning rapidly. So what significant problem could this particular situation cause for you right here? Just imagine that you happen to possess a substantial number of these various variables. You would always have to remember what each number stands for, what 1 means, what 2 means, what 3 means, or whenever you want to use these numbers in your code and assign a specific state to this variable, you'd have to go back to wherever you wrote the comment for this variable and check which number corresponds to the specific state you want to assign now, and then use that. Another problem that can happen is that you might mistakenly assign the number 5 to this variable that, for example, you defined as market status. And as you can see, if I compile this, except for this warning, which is related to our own code, and we'll get to it later, the compiler doesn't show me any other error or issue. So what can happen is that you assign an incorrect number outside of the limited set of numbers to your variable, even though your variable is only supposed to hold a limited number of states. To address this problem, we use enumerations. To define enumerations, all we need to do in MQL5 is write the word enum in lowercase, then give a name to the enumeration. I'll start with enum. This is going to be an enumeration. Let's say market status. And then I open and close curly braces. And at the end of the braces, I put a semicolon. As an unwritten convention in MQL5, we write these names in uppercase and use underscores between them. And this is how we name them. So we had 3 states in market status, which I'll write here again in uppercase: market uptrend, market downtrend. And market range, which we work with. So 3 different states have been defined. What this enumeration does for us is that implicitly, it actually uses integers to assign numbers to these states. The first one is automatically set to 0, the second to 1, and the third to 2. We can manually assign these numbers ourselves, as I've shown here, or we can just leave it and let it be done automatically and not worry about it. For now, we won't assign numbers when defining this enumeration. Notice that here, we've only defined the enum itself. We haven't created a variable from it yet. We've defined a specific data type called an enum with this name. It's as if we've defined a data type like the integer type. So from this point on, we now need to actually define our variable market status, but its type should be this enum. For this, I no longer need the old market status. I want to convert it to an enum. So next, I use the name I chose for this enum, set the variable's type to the enum. As we said, the first word you see in variable definitions is the variable's type here. It was integer. And now it will be enum market status. I'll name it market status again. As you can see, if you pay attention, the naming conventions here are different. Here we have used lowercase letters for naming because its type is a variable. But for the enum itself, which is actually a data type, we use uppercase letters. All right, now, when we want to assign a value to a variable to this enum, meaning to assign a value to this variable, we use the exact expression of each of these. For example, market up to down or market, enter in, and if we compile it, as you can see, it doesn't show any problem for us. What happens here is that you can no longer accidentally assign another number or a variable outside of these 3. The case is you defined yourself in this enum to this variable, and it makes your value assignment completely precise. Also, you no longer need to go back and look at the numeric value here to see what it means. For the definition you've made, this expression itself, since it's a name and acts as a label, conveys the meaning to you. It's enough to just include the necessary explanations and the naming of the different states of an enum. Pay attention to that. And from then on, you won't have any problems. For example, if you want to define our next variable, which is candle status, as an enum as well, we say enum candle status, and here we also need to delete this again because we don't want to use it. So what problem did we encounter here? We defined a variable here of the type enum candle status, but we haven't actually defined the enum candle status itself yet. So we need to say enum candle status. And just like before, now we can add the different states we can consider for a candle here. For example, we can say candle spike mean or candle standard, or for example, candle could be spike. You can add as many as you want here. There are absolutely no limitations. All right. Here as well, we can come and assign the variable candle as a model candle statistic, for example. As you can see, the options are specified here. You can use this list as well for assigning these variables. The next type of variables are structs or structures, which are considered as data structures. They are, imagine you want to store a set of information related to a specific object, all in one place. For example, if I want to keep a student's name and grade and also consider their age in a single set of variables. For example, if we want to store these three variables, name, surname, and age for 3 students. If we want to do this in the usual way, we would have to define a string variable called student name1, or maybe it's better to write it like this: student name1 and their name. For example, let's set it to Jack. Then we proceed to define another string variable, which we will call student name2. It is important to note that we specifically need to ensure the word student is spelled correctly and accurately here. And set its name, sep, and define another string called name and set its value, Peter. So we've defined the names of 3 students. Now, next we want to define their ages. So for example, student could be 15, again, another integer value. For example, it could be 25, keyboard. If it cooperates with us in writing, for example, it could be 21. And next, we also want to have a variable of type double called GPA for storing, say, 3.5. So we've defined a set of data for 3 students. And as you saw, we had to define a lot of variables. But isn't there an easier way to do this? Can't we do it in a more concise and cleaner way? Why? The solution we can use is to take advantage of structures or structs, to use structs in this case. All we need to do is write the word struct at the beginning, just like when defining an enum, and then define that structure. For example, I'll name this structure student struct, meaning it's a structure of type student. This naming is completely optional and entirely up to you. You can use any name you want here, but unlike those other names, we don't use capital letters for naming here. Here, just like the different types of variables we had for defining things, we use each of these data fields for a student inside the struct. For example, the first variable we had was a string, which was for the name. So here I define a string called name. Note that here we end the line when defining these types of variables with a semicolon, and unlike the enums where we used commas, here we use semicolons. Well, the second type is of type int, which represents our age. And the third type is double, which represents our GPA. So what can we do here? instead of defining a large number of variables to represent our students, let me comment these out. Commenting them out, in the previous session, we learned that we can use \* and at the end */ to turn all the lines in between into comments for defining the students. Now, I can very easily set its type to the struct type that I defined. That is, I can create a student struct called student1, and then create another student struct called student2, for example, and another student struct called student3. By doing this, we avoided defining 9 variables. And with just 3 variables, we were able to compress them into each of these structs. But how can we use these structs or structures in our code? Right now, we've defined a student called student1, but how can we access the values inside this struct in order to access them to these values, that is, to know the name, age, and GPA of each student in our struct? It's enough that in the function where we want to use it, we just write the name of our variable, which I've written here, and then put a dot after it. After the dot, you'll have access to all the variables that have been defined as members in this struct. So all I need to do is select name here and put name here. What did we set it to here? It's Jack. If we consider the scenario where student 1's age was precisely 15 years old, and then we also take into account the age of another student, perhaps student 2, for comparison or further analysis in our dataset, his GPA was 3. And in the same way for the other 2 students as well, I added them here. And as you saw, assigning values to our variables became much easier and neater. As we mentioned before, when you use the equals operator, the data on the right side of the equals sign is assigned to the left side of the equals sign. But if you want to access the data of any of these, you just need to use this dot notation. For example, if I want to get the name of student 2, I simply use the same dot notation and access the name variable. I find it, and here it will print it for us. Let's compile and run this once. Let's compile it. And from our data type folder, which was here, we run our indicator. And as you can see, SEP or SEPasian is displayed here for us, which is the name of our student number 2. A question that might come up for you, friends, at this point is, well, you might say, Mobin, if we didn't have just 3 students and instead had 300 students, what should we do then? Should we come and define variables one by one like this, up to number 300, and define 300 variables for each of these students? The answer is here. If your variables, which in this case we can call objects or instantier of a specific type, that is, if all the variables you had and wanted to gather together were of the same type. You can use arrays, and it's arrays that come to R8 here, thanks to the features they have. So you can use a specific data type for all the elements of that array. Also, you can access the data you have using an index. For example, let's say we have toys. We use them in this array, and instead of saying teddy bear toy, we can say our array at index number 4. Also, our array can have either a static or dynamic size, meaning you can define an array that can only hold exactly 4 items. This would be a static array, or you can define an array whose size can change in the future. In fact, you set the size as a variable, and this becomes a dynamic array. Also, in optimization, our memory, when we use arrays, our memory is allocated more efficiently because all the objects we have in that array are placed sequentially and one after another. Also, arrays can be one-dimensional or two-dimensional, and as you can see, we also have multi-dimensional arrays. In MQL5, we can perform mathematical operations on arrays. For example, we can reverse arrays. We can arrange them from start to finish, search through them, or add or subtract something to all elements of the array. And similar mathematical operations that are available for arrays in MQL5. But how do we define arrays and how do we use them? As we mentioned, we have different types of arrays. There are static arrays, which have a fixed size, and dynamic arrays whose size is variable and can be changed. To create an array, first you need to specify its type, which must be a fixed type. And as we said, all the elements inside that array must have the same type. We need to write the type at the beginning and then assign a name to it. Here, the type we want is student struct, as structure. We create an array of this type and assign it a name. For example, here I'll name it student error. And at the end of the name, we add 2 brackets, open and close. We let our compiler know that this name is an array, but it has 2 forms. This bracket that we put here, if we put a specific number, a constant, as an integer, if we enter it here, our array will be a static array, its size will be unchangeable, and we will always use it according to that size. For example, if I'm sure that I only have 10 students, here I put the number 10. I put it here, and I know that this array of students I have only has 10 elements, and I won't be able to change it later. For now, we'll proceed with static arrays so that we can cover dynamic arrays in the future. So now, how do we access the members of each of these arrays? What should we do? Well, at this point, I think it's necessary to delete these variables. Because we've already put everything into the students array, we can also remove the value assignments here, and then we move on. Next, we want to see how we can, for example, assign names for 3 students. First, do this naming in this array. But before that, let's get familiar with the concept of array indexing. If this is an array for me, normally to count this array, we would start from the number 1. We'd say 1 first element, second element, third, fourth, fifth, sixth, seventh, and eighth. This is the normal way of counting that we use in everyday life. But in most programming languages, counting doesn't happen this way. And arrays are no exception to this rule. We call this zero index based. What does that mean? It means that the first number assigned to us in our counting sequence is 0, not 1. In other words, it starts from 0. We start counting 0, 1, 2, 3, 4, 5, 6, 7, the number of elements in this array. As you can see, there are 8, but it starts from 0 and goes up to 7, or 8 minus 1. So the length of our array is always 1 less than the total number of elements in our array. That means if I have an array with 100 elements, I should always know that the index of the last element is 99, which is 100 minus 1. So keep in mind that the numbering in arrays starts from 0. So if I want to, based on this zero-based indexing we've learned, assign a value to the first student, set their name, age, and GPA. First, I need to access the name of the variable itself, which is our array. Next, with open and close brackets, I access the index number of the element inside my array. For example, if I want to check or assign the first element, I need to put the number 0. Why? Because we said that arrays in programming languages are zero indexed, or to put it better, in most programming languages, and as before, I use the same syntax, name and jack, and as you saw, instead of creating a lot of variables, we just created one variable. And by using the index, we access the members of that variable, which was an array, so we can move between them to enter the information. Okay, I'll enter the age and GPA. Next, we move on to our second student, which is at index 1. Here we will have access to it. We set their name as before, age, GPA, and this is the second student, so I've initialized 3 students here. And I can continue with the rest of the students as well. I can initialize them, or just like before, use dot notation to access them to those variable values. Here too, we can use dot notation to access their values. For example, now I want all 3 of my students I want to print their names. So in the first line, we know that the student array, or the variable where my students are stored as an array. I extract the name of the student at index 0, and I'll have access to it using dot notation. To the parameters that we defined inside an extract, which is one of these parameters is name, and I can access it using dot notation. All right, let's go ahead and compile this indicator we've written. If I click the compile button and then open my trader, since this indicator was already placed on the chart once, it's already been executed, so I'll remove the indicators from the chart and then add this indicator, which is named name. Again, as you can see, in 3 lines, all 3 names that I had set for the 3 elements of the 10-element array. It also printed out the one for students, so that's done as well. How to use arrays in defining variables that are all grouped together as a set of the same type. Not that they are of different types. Well, here you can see that we created an array of type extract, but we can also create an array with different types. For example, if I want to get the open prices of the last 10 candles in the market and actually store them in a variable as an array, all I need to do is create a variable, define it as type double, and name it candle open. And then let's say I don't want just 10, I want to store, for example, 50 of them in it. So now I have an array with 50 elements and its type is double. It's no longer a struct type, just 50 numbers of type double that I can store in this array.